Hi everybody, I want to take you through a presentation on how to utilize technology in the education process. I've got a little channel that I've set up, and there's some information there as well. I'll take you through it. What I want to do is give you an overview of what my thinking is and give you some ideas and how to get started, and then also key considerations. So I hope you enjoy the presentation. Sit back and relax. So first of all, it's quite important to understand how everything fits in and the choice of technology. This is from a technology point of view, coding point of view. I kind of like Scratch because it teaches you the basics. And then you will see there at the top the microbit, which is quite a good little electronic computer, which you can then utilize to integrate your coding with the. I like to utilize for free stuff, so SQLite from a database point of view, and then there are some other popular programming languages and scripting languages that I also utilize. You will find that when we start off with the juniors, it's important to utilize sort of the same techniques that you would utilize when you are at university or even in the job market. I think it's important at the moment where what we found is that popular languages would be C++, C Sharp, and Python. And what we want to do is to, when we start at a junior level, to actually install those disciplines already early, utilizing something like Scratch. And then we move on to Microbit. Microbit has got the ability to also, I mean, it's coding blocks, but it's got the ability to align to things like HTML and JavaScript and Python, and that helps with programming. Then from there on, it's important also to utilize some of the open source information that's there. Now, Microsoft MakeCode, what they've done with Microsoft MakeCode is that they've created intermediate coding blocks, and those then align and can be translated into the programming language that you would use when you're an adult. Okay, who am I? Well, I'm Henny Jansen van Rensburg. I've been an IT partner at a large consulting firm. I've been in the IT industry for 26 years. Most of my clients are banks and insurers. I've got 2 children, but I also keen little coders, and that's where I started with the interest in coding. I've also started to help with coding at various other places. I'm also involved with universities where I am teaching project management and coding, and I'm a mentor for a number of students. So I've got a keen interest in teaching. I've got a keen interest in developing staff, obviously, for industry. Like I've said, I'm also a qualified chartered accountant. I've got a strong programming and finances background. Some of my information is below. I just want to move that. Where you can get hold of me if you've got any queries. Okay, just going to move one back. Effectively, what for me, digital is a way of living. I think what is important is that when we take the coding process and we utilize or integrate it into a learning process, it's important that the learners know how to gather information. Now, in the IT sense, there are all sorts of sensors out there, and that is normally utilized for gathering information. There's also human intervention, where there would be physical observation, where you would record your data and you would do a data entry. From there on, you move into handling that data or classifying the data, making sure that there is proper record management. You will apply your calculations and algorithms, whether it's a scientific process or whether it's a financial process, or if you gather data for a social science project, you would perform certain levels of calculations, and then what you will do is you would set the parameters for input and processing, or input processing and output. What do you need to do? How do you deal with variables? Because those variables also link into calculations, and it links into the input parameters that you need for gathering information. From there on, we move over to then utilize coding and electronic techniques to process the data. It's important that you know how to integrate all of that in the final solution, and then also utilize reuse. I think the principle of reuse is quite an important one in the programming world. So I think from an early age you need to install that discipline of being able to reuse what you've done and not reinvent the wheel every time. Then there is the question around execution, how to troubleshoot. Many of our kids, many of our adults do not know how to troubleshoot, how to correct incorrect outcomes. Now, when you deal with IT, nothing works the first time perfectly. So troubleshooting is quite an important element in terms of, and there's a number of techniques involved with troubleshooting. And I think the last part is then, how do you present what you've done? How do you visualize what you've done? Are you able to tell the story? So you would see that there's quite a number of left brain and right brain activities in the solutioning process when you utilize technology. Now, I mean, if you look at the world is basically, and from an early age, the world has been code. What you would see here is, on this little picture, you would see a robot. The robot or traffic light would be pre-programmed to control the traffic. And there are codes, and we as humans would process those codes. Like, for instance, green means go, red means stop, yellow means slow down, although some people speed up. Then also there's some information lines, like the lines there. The person knows that somebody would be crossing, so they might consider slowing down. They should consider slowing down. So all these lines are processed and all these codes are processed by the human brain. And what happens is that we, from a young age, are already coders. So teaching coding becomes quite natural. And what you would see is that we also are able to gather information, whether there are people on the side of the road, whether there are features, physical features, or whether there are a dog that's got the chance of running in front of the car. We will gather that information, identify events, and process accordingly. Programming works in exactly that same way. Some events have got a sequence, like, for instance, when I drive, I need to stop at the robot or the traffic light. I need to turn right. I then go down the road, and that is then a sequence of events to get to a destination. In between the sequence of events, other events, involuntary events, could also happen, which I need to react to. Now, the same in programming, that I need to handle voluntary and involuntary events, which is quite important. Now, what are the 12 traits for teaching coding? First of all, the willingness to explore. It's quite important that we are willing to explore. Teamwork and facilitation. Now, with IT, normally you work in large teams and most of these technology projects have got a lot of teams, and a facilitation and teamwork skill is quite an important skill. We also learn from other sciences, so you have to integrate, or willing to integrate, other sciences into teaching technology, because it's not only about being able to program, it's being able to deliver a solution that is fit for purpose and has got a purpose. It's also the ability to deliver rounded artifacts. So in all other academical disciplines, if you've got 70%, you've done pretty well. In programming, your program won't work. So it's quite important that you are able to install the discipline of doing and delivering rounded results. Sometimes you could have a brilliant program, but the outcome is not well explained, and the story is not told, and that program is then not well rounded and might be misinterpreted, the outcome, or misunderstood. I think the other important thing is the ability to put the puzzle together. Normally, in the coding or programming world, what you would have is you would have lots of little components that would be developed by different teams, and someone would, or a team would put together the puzzles and integrate the full solution. Then I think the other thing is that, and that's where the ideas part comes in. With programming, a solution might not work. So that ability to innovate on the fly is just as important as being able to utilize all the teaching techniques and programming techniques that were taught to you. Understanding the technology capabilities. So I think underlying to technology and programming and coding would be that you understand the devices that you work on and the technologies like the sensors, like the ability to calculate, like the ability to utilize and gather information through devices. I think I've said that before, being able to tell the story throughout the journey. So what we need is a good presentation skill. We need to be able to sing and motivate the team. We need to be able to inform the people on the outside, the stakeholders, whether that's now the user or whether it's a teacher that's teaching coding. They need to understand where you're at. You need to be able to tell that story, articulate that story. What we found with technology is continuous research and improvement. Every time there's something new, one would introduce that new technology into your system. Now, the same thing with when you teach coding is that there's a continuous research and improvement required, but with that comes also understanding the discipline that you apply the technology to. So if you apply technology in the scientific field, you also need to understand the scientific processes and the outcomes from those processes. So that installs quite a good discipline in terms of the ability to research and the ability to seek improvement. What is quite important in teaching coding is that you have the ability to get across that design is quite important, and that design is probably half the battle won. So designing with sustainability in mind, so designing being able to maintain the what you've done, that somebody else can also use it. I think I've mentioned that before, is execute with precision. That is, coding is like science. You need to be quite precise, otherwise you might get outcomes that are not necessarily reliable. Then key for me is perseverance. I have yet to see a program, even a little program, that works the first time. So you need to stick at it. You need to be able to troubleshoot, to fix, to try again. And in the programming world, an error is not a mistake, it's a data point, and you need to react to the data point and learn from it, and then also learn how to troubleshoot, which means that you need to fix bugs. So those are key disciplines that we see that are important for when you teach coding, and also when you apply coding as an adult in the industry. Now, the strategy around the learning of and how you teach coding is basically simple. It is making sure that you, from an early age, establish the key disciplines for and concepts, the ones that you've seen there before. And you need to learn your devices and learn the basics around how coding blocks work and how pieces of code work. What are the tools for writing a program? It always is important that you celebrate your results. You learn how to troubleshoot, how to progress and integrate with maths, art, anything you want, and teach coding combined with other subjects. And you will see the integration is quite important. And there, with the integration, you can introduce fun by introducing more sensors or sensory type inputs. I think it's also, as you go on, you will get better and you will be able to utilize advanced coding blocks. Eventually, you will translate them into introducing the skill of scripting and programming languages. Because if you introduce programming languages and scripting too early, you would get the learners confused. It's important that they understand the building blocks. Coding is very much like maths. Without the building blocks, it's quite hard to move on to more advanced coding. And I think the other part that's important is that with this, if you teach it in teams, you also introduce the importance of teamwork and utilizing other people's skills. Because in the real world, no single person knows everything. And normally, when we do coding, we need a lot of other disciplines in there. I've made a list of the everyday skills that we require in the sort of industry and where we are involved in business. Now, I think this also applies then to coding. Now, what are these skills? I mean, if you look at the categories, a lot of these categories that we utilize in coding are actually coming from other disciplines. They're coming from like natural language processing. I mean, language rules, way that you express. We utilize that in natural language processing. The way that you deal with scientific formulas. How do you deal with electronics and device programming? You need to understand electricity and circuitry. So you can install quite a number of other disciplines and teach quite a number of other disciplines while teaching coding. And the other way around as well, all these disciplines are also quite important when teaching coding as building blocks. Now, the coding concepts are fairly stupid or simple. I shouldn't say stupid, but they are fairly simple. What we do is it's important to teach commands and actions. It's important to teach the basics around variables and how you calculate the functionality around robotic functionality and understanding the robotic and sensor functionality, which is understanding the devices, which is more of an engineering concept, where command and action is something that you would do and variable in calculation that you would do in maths, where the robotic functionality is more of science and engineering, but you can integrate it all into your concepts training, and then at the beginning, when we start with the primary and pre-primary kids, we would start with coding blocks, and then we will move over to Python and coding, Python, C++ coding, and Java coding, JavaScript coding. So what is important? First of all, gathering the information and recording the information. Now, what you would find is that there are some key aspects that we want to install when doing that. It's first of all observation technique. Second of all, how do you record data, how you deal with anomalies, and then from there on we will move over to the scientific process, where we can utilize the scientific process to actually deal with testing some scientific formulas and the effect of those formulas under non-ideal circumstances, real-life circumstances, recording the data, analyzing the data, and also code in the process. So here's an example of how to measure speed and distance. You've got the scientific formula there, which is a mathematical formula on the one side. On the other side, you've got your tools, and I'm utilizing two robots. One is got it's a sphere, and it can move probably a lot faster than a normal robot that's got little wheels. Now, what you would find is that there's some coding that we will utilize, and then the robot would actually run down the track. We would then utilize sensors, and these sensors, and also a speed recorder or a speed trap, and we will record the information. We'll then test the information that we've recorded against the formulas here, and we will, out of that, we can then determine whether the formula can be applied effectively and following a proper scientific process. So now what you've noticed is that what am I teaching? I'm teaching science and maths. I'm teaching data recording. I'm teaching the whole idea of ideal versus lab circumstances. I'm also teaching some electronics and circuitry if you can. So depending on who it is, if it is a younger child, then we will teach some of these concepts and the others the teacher would do. And if it's an older child, they can do it end to end. So this one we will use the microbit with sensors and circuitry to measure the result and then display the result back. The next one was a plant with growth. Effectively here we want to teach biology and the whole germination process, and we want to test the effect that that light, water, humidity, and soil and those conditions have on the growth process. And what you would have there is you would take the different circumstances. You would have some of your samples not being watered properly, others would not have proper lighting, others would have ideal circumstances, and then what you would do is record the information, and then over time you can see maybe a 7-day, 14-day, 21-day period, you would see the change on the various with the various samples, and then you can see the effect of light, moisture, pH, or humidity on the growth process. Now, I think what is quite important is that the integrity of the data that you've recorded needs to be managed and in being able to tell the story. So when we then teach that part, we will install some of the more important processes like data handling, data quality, data analytics, analyzing the information, coming to conclusions. The utilization of coding blocks, I've mentioned that before. So in effect, when you're younger, you will utilize coding blocks in a simplistic way. This one is what it does is if you press a button, which is button A, it would then repeat a process 4 times. If you press button B, it would repeat a process 5 times. So what you could do, and that's the thing, is that for younger kids, or younger learners, we will utilize the coding blocks to learn how to program. And then as you become more senior, you will start to translate it into one of 2 programming languages, which is either JavaScript or Python, which is also utilized at university and then at within industry. Now, I mean, yes, another example, utilizing coding blocks using Scratch. And effectively, what we will do here is we will run a Scratch program and teach someone to do a fun game, or even geometry and all mathematics, where we would deal with drawing a object of some kind and then understanding the properties of that object. Now, from a visualization point of view, I think there's 2 parts to it. The one is that in terms of data handling, and I know that's quite an important mathematical concept, that we be able to visualize in terms of managing graphs, or on the other side, you could utilize, and that's more of a fun one, is you could utilize visualization to explain movement, and by writing in games that where objects can move, and with that then comes all the mathematical concepts, and you would notice there's all the coding objects that you would utilize, and it's the same coding blocks that you would have seen here and here. So the theme comes through that what you learn in the one, you will be able to utilize on other programs. So we normally select programs that are similar. And then in terms of coding, it should be easily translatable into the proper coding that you would utilize at high school and university levels. So if I bring it together, first we start off with a problem statement. We need to do some discovery. We would need to define the features that we would need to solve the problem statement. We would define the quality statements requirements, so meaning what is right and what is wrong. We then would utilize all of our tools to be able to build an architectural plan of how do we resolve the issue. That would include a concept diagram, flowcharts, mind maps for some of you that like to use that concept. And then we would gather the enablers, meaning the equipment and what we need to do. We would start with what we call sprints or drops, where we scientifically then, as part of an agile process, we'd have little sprints where we would solve the problem and then work as a team. And then finally, we would actually, the drop is effectively a outcome. That outcome we would then be able to deliver in terms of a presentation, and then we also will visualize the outcome into a graph or a display story. So that's sort of the process, the teaching process behind this. And I'm going to pause at that.